questions we will take in the chat box and then attend to them at the end of the talk. And apart from all that, I'd invite Sean and colleagues to get started.
Okay. Thank you very much, Jerry. Much appreciated for the introduction. The subject of today's talk is the NPL scrapbook system that currently is at the National Museum of Computing. Our job over the last few years has been to start trying to revive that system, restore it, get it back into a workable state, and that's what this talk will cover. So first of all, when I select the right screen, there we go. Myself and Ray and Richard and Malcolm were the team that have been working on this since we originally started in 2017. And we've all got a long history of DEC without actually working for DEC. I believe, I don't think Malcolm and Richard worked for DEC, and I know I didn't and Ray didn't, but we worked for several DEC OEMs, including ICM, Phoenix. Systime is where we all started. I also worked for a business called Croft. And we've been involved in many areas of the whole DEC story, including field engineering, workshop engineering, technical support, and so on. So we all travel down once every couple of months. It was every 2 months before COVID. Then obviously we had a long gap, but we're getting back into that now and getting down. We tend to spend from early on a Saturday morning right the way through to as late as we can on the Sunday, working on it before we drive back north. So a little bit of history about me. I started working for Systime, who were a DEC OEM. They built their own computers, but they also built OEM systems based on PDP and later VAX as well. So I started there when I was 16, too many years ago, and I moved from Systime to a company called Croft in 1986, where I supported customers pretty much from Nottingham up to Edinburgh. They were all PDP customers, so it was all predominantly Unibus in those days. And then, as time went by, ended up moving on to the QBus systems. I ran the repair center for Croft. We did a lot of component level repairs on Unibus and QBus systems, and also peripherals, printers, monitors, and so on. And for a day job, I now run cybersecurity consultancy. But I've taken 2 hours off to go through this introduction and this presentation. So I want to hand over to Ray now, and Ray, he can introduce himself and his experience.
So, yeah. Okay, as per the slide, really sums it up. I started off as a TV engineer when I was younger, before coming into the computer industry. Worked for Corp and Granada TV rental. Joined Systime in 1983 and made the move. I was taken on as a terminal engineer. So I spent 3 years doing that and then started working on processors about 1986. Field service mainly. We had a little workshop at Systime within field service where we could do our own component level repairs, etc., and testing. From Systime, I joined ICM, Independent Computer Maintenance. That was started up by a guy called Barry Roberts. And I was there specialising later on in datacoms as opposed to processors, etc. I then went contracting in 1998, where I worked for BT up until I ended my career, basically, about 5 years ago. So I've not touched the PDP 11 since 1998, starting in 2017. So retired and enjoying the scrapbook revival. That's me in a nutshell.
Great, thanks, Ray. Malcolm, I'll ask you to do the same, mate. Do you want to make sure you're unmuted?
all buttons around here. I joined Systime in 1980, so I was quite an early joiner out of us three. Straight into the workshop, started working, fixing power supplies, and then progressed upwards through printers and monitors and stuff like that. And then eventually I got onto repairing PDPs. Started off with the 1144, which I went on a course in Reading with DEC, and I was an extremely good course. Doing the 1144, I then went into the 1134 and also the 1170. After a period of doing all the PDP stuff, I then went into the VAXes. I specialised mainly in the 780, although there were a lot of micro VAXes that I took part in as well. OEM storage devices, yes, CDCs like RMO3s, RMO5s, SE Labs tapes to a certain extent, and DEC tapes, TU80s, TU81s and the like, stuff like that. In 1986, I joined ICM as well and went into the tech support part of things. But as I didn't like being woken up at 1 o'clock in the morning, I came out and started a workshop there. Stayed with the workshop until it was sold out, unfortunately, in 2008. No, was it 8? I think it was, yes. And then I did a few years of doing nothing, repairing my house mainly. I then joined another company, sort of basically in the workshop, but not necessarily fixing DEC stuff. I didn't really like working there, so I came out and retired. And now, like everyone else, I'm retired and enjoying Scrapbook very much. And that's me in a nutshell, Fish.
Brilliant. Thank you, mate. Thanks, mate. And so, Richard, if I could hand over to you, do a bit of an intro.
Okay, hi, I'm Richard McDonald. I started like Malcolm and Ray and in fact Sean at Systime in 1982 as a bench engineer, working on the VDUs and some of the S-series products that Systime was specialising in, their own specific computer. I then moved on to specifically component level repair of PDP-11 unibus-based systems, 1104s, 34s, 44s and 70s. And also worked in the tape drive backup systems. That took me through to about the early 90s, where I moved into management responsibilities, waking Malcolm up at 1 o'clock in the morning, which of course he didn't like, and stayed in that role within ICM for a good number of years, and then continued to work as a project manager basically in IT deployment and service delivery contracts. I retired in 2012, and since then I've maintained an interest in IT and the various technologies surrounding IT, and joined up with these guys in late 2019 to get involved in the 1170 scrapbook system, which is a remarkable piece of equipment and a fascinating subject matter to work on. So that's my history, and I'll push that back onto Sean now.
Thanks very much. Great, nice introductions. Thank you very much, everybody. So what I want to do now is just go through a little bit. You've heard there we mentioned Systime quite a lot. Systime were a business that initially started by creating their own systems, which ultimately were a PDP. It was essentially a PDP in a really big box full of air, and they did the 1134, which is the Systime 5000 and so on, and they also did their own systems based on 8086 and latterly some OEM versions based on the VAX 750, 780s and 785s and so on. So Systime got bought by CDC. CDC got bought by DEC. DEC got bought by Compaq, and Compaq got bought by HPE. And obviously that got diluted and in essence doesn't really exist anymore. That was Systime. That's where we used to work. It was quite an innovative and impressive building for its day. probably I think it cost something like 25 million to build in the 80s. You wouldn't get that now for that sort of price, but it was they were well known for their glass palace, which is where we worked. So moving on a little bit to now the museum's deck systems, they've got a nice collection of systems, some operational, some not, right the way from the PDP-8 through to quite a substantial VAX-FT fault-tolerant machine that's in storage, and everything in between. So we're here really today to talk about Scrapbook, and Scrapbook was a hypertext-based system that was built by the National Physical Laboratory. The reason that it's so important is that it uses hypertext, but it was in existence several years before Tim Berners-Lee invented the World Wide Web, which is it's quite similar, to be honest. It's along the same line, so it's historically an important machine. We believe this specific machine we have was last operated in 1988, and we've got that dated from the filters in some of the drives. Typically RMO3 drives we used to perform preventative maintenance on them every 6 months or so. So of course you would write the date on the filter, and that was the last time that those filters were changed in 1988. The Scrapbook machine itself is a deck data system 570, which is essentially a PDP 1170. It's an 1170 with a blue front panel, I think, in essence, is and probably a different cabinet, but the CPU, the memory and everything is a PDP 1170. The 1170 is a 22-bit address bus machine. It's our specific machine has 512K words of memory in there. It's MK11, which is bipolar memory, as opposed to the MJ11, which was core memory. And I broke fingers on those in the past trying to lift them. And the Scrapbook system has two mass bus controllers in there, one for disk and one for tape. There is no tape drive with this Scrapbook system, so we think that got separated at some point in the past, probably never to be reunited, unfortunately. And it also has two DEC RMO3 disk drives, which were 67 megabyte removable disk packs. One of those drives, we believe, was probably the live system. Everything seemed to run off one pack. And the other one was probably for taking backups. And referring to the packs, the museum, it owns a set of packs, probably the last set that we are aware of that remain anywhere. So there's a big responsibility here, really, of being able to, first of all, build a system that will read these disks, and then getting into a position where we can safely actually read them. So PDP 1170, if you do or don't know, I just want to do a bit of a top trumps and a comparison between the two. So comparing an 1170 with my MacBook that I'm running on here. There's a significant difference between the two, as you can see. The most important, though, is the desirability for me. The desirability is a 10 out of 10 for the PDP 11. We run a job on some of the operating systems called a sysgen. And a sysgen is basically a configuration exercise that configures the software to use the correct hardware that it has. To run that on the PDP 1170 tech, it took 48 minutes. And when I last run one on my Apple Mac in an emulator, it took 9 seconds. So it gives you an idea of progress. So really just talking about the 1170 itself in early stages, I've got some photographs here, and Ray, I probably need your help to talk through a lot of these. If you want to unmute yourself, and you can probably give some insight on what's going on in some of these photographs.
Okay, sure, that's unmuted, yeah. Yeah.
So that's the Scrapbook machine. It looks a bit scrap. Obviously, it was when we started working on there. Some points of what we can see there is in the bottom right-hand corner, there's an RK05 disk drive. We believe that's not a part of Scrapbook. It was just put there for storage. So since then, it's gone. So Ray, do you want to talk through a couple of bits on this?
Yeah, as you can see, the front panel, Sean mentioned the actual model, the Data System 570. The only difference is this blue and white grey type front panel, really. We believe it was, I think it was built for the also medical industry and places like that where it was maybe on show, so cosmetically preferable to the other variant, which you'll see in later pictures. The museum provided two 1170s. So the blue one, which is called the blue one, that's the actual scrapbook hardware, and a spare machine that they purchased, which we call the purple machine, as you'll see later. That was our basically spares kit to get the scrapbook machine working. It turned out initially that the spares machine actually worked better than the scrapbook machine. So early repair attempts were on the spares machine. And later, at a later date, we eventually transferred the memory box from the spare in its entirety into the scrapbook machine, because the memory box, prior to our involvement, had suffered some basically bent pins which had shorted down to ground. We don't know how that happened. The only other thing I'll mention about Scrapbook, the operating system that it ran was called IAS. I think it stands for Interactive Application System. But for the deck people on here, that's just a variant of RSX 11M Plus, which is a better known operating system. What you see in the picture now, yeah, is just the graphics of the upper and lower major power supplies, which feed smaller power supplies, which power various slots in the CPU cabinet. Just an example of the equipment that we use for troubleshooting. I recognise that as the clocks from an RLO2 drive that I was trying to repair. Took 2 days. I ended up not having a terminator. That was the problem. There was a lot of troubleshooting involved to get to the fact that the terminator was missing.
You live and learn.
Yeah.
So this is a video of, I think this was an early memory diagnostic that we loaded up through the front panel, I think, wasn't it, Ray? That we did.
Yeah, they were all machine code programs manually loaded from the switches. Yes.
Yeah. So hopefully you can hear this. You can hear the singing power supplies.
Yeah, that's just a counter, just counting up from 0 up to some maximum 16-bit value, I guess.
Yeah, which was quite an achievement to get that far, to be honest, from what we started with, wasn't it?
It took ages to get to that point, didn't it? Yeah.
Yeah. So, trying to move on. There we go. So another view of the front. We'd swapped the RK05 for the RLO2. The RLO2 just being a much more stable workhorse, really, and no shortage of packs or media or anything like that. And the panels in the bottom, Ray, were they from a DH or a DZ11?
DZ11 asynchronous multiplexer distribution panels, yeah. So 16 lines on each one. So 2 DZ11, which was an 8-line MUX. 2 DZ11s to each distribution panel.
Right.
For the asynchronous terminal connections that they used.
Good stuff. Okay. So another view of the front. I think this is all right. This is another. I think this video is when we first actually managed to get it running operating system. It's running the RLO2 there, but it's also got a Fujitsu 2322 disk drive, which I'll come on to later on in the presentation.
Yeah.
But this the lights on the PDP-11 front, you can identify what operating system it's running pretty much by what the lights are doing. And this is a typical Rista system.
Before you start, Sean, look out for the power cut.
What, sorry?
Sorry? Yeah.
Yep. Sorry, Ray. I think I might have.
Yes, during the video show, the lights went out and came back on again. We had a very short power cut, about half a second, didn't we? And the machine kept running.
I kept running. Yes, it did. That's right. Yeah, that was incredible. So that was the first time we had it running an operating system proper, wasn't it?
Yes.
Good stuff. So, so the main issues. I mean, some of these actually. Malcolm, you might have some input on this, and Richard, because we've had issues with the 1170 since the start, and I think it was only the last visit that we were down there in what was it, a month ago, maybe 6 weeks ago, that we actually got to a point where the 1170 is now absolutely perfect and passing everything. So, Malcolm, have you got any comments on this, and Richard?
Well, the main problems were the memory box is external to the actual 1170, and they're connected by 4 40-way ribbon cables. Now, the problems with these cables is, like, most cables are multi-core. They've got more than one cable. The deck cables only got one core. So if you flex it a few times, it breaks. And the only way to find it is that I built one of these. Can you see it? It's a cable tester.
Have you got it on your screen?
Yeah. No, I haven't got it on screen. I'm going to have to do that.
You're just showing it on the front, yeah?
Yeah. I couldn't find it. That's why I didn't it. It took a while to build, but that fixes any cable within. Well, it doesn't fix. It shows you whether there's open circuit or a short circuit. It finds faulty cables effectively, and we discovered we had quite a lot.
We did.
Rich, any more to say?
No, I'd just like to add that prior to my involvement with this, the Ray, Malcolm, and Sean had actually brought these machines to life. And the problems we encounter is that they're extremely temperamental. So on my first visit, it was a case of 1 step forward and 7 or 8 steps back. And these machines, for any of the deck guys who are on this call, will remember that they are extremely sensitive. Cache control on cables being the motto for 1170s. So yes, every time you move the cables, you'd have problems. And on our last visit, we were quite fortunate that through some extensive troubleshooting, component level troubleshooting, we could prove that there were some really strange cable faults going on, so we were able to resolve that. So that was quite an interesting process. I don't know whether Ray might mention a little bit more about it later on. But yeah, that's my only real input on this at this stage.
Okay.
Yeah, that was a long-standing fault that used to go away and come back. We thought we'd fixed it about 3 times. It just exhibited itself on the diagnostics only, when the diagnostics simulated a parity error and then checked whether the CPU could detect that parity error, and that test wasn't happening. And that diagnostic failure plagued us for months, going away, coming back. We finally fixed it on this last visit, which was good.
Yeah, no, it's interesting. I mean, there's been, like Richard said, there's always been situations that you always take a few backward steps on every visit. I think so far we've done that. I think the last visit was good insofar as we've got stability now in the 1170 CPU. But yeah, there was many times where you'd fix something, come back the next time, and all of a sudden something else had gone wrong. Stuck bits were something that occurred. We had a couple of stuck bits on boards, didn't we? As well, did we do them to? Did we repair them to component level, or are they on the list of things to repair once this is done?
We used to stick wires onto the chips and sort of hang them outside, and then monitor when the diagnostic was running to see if the signal was good, reflecting what the diagnostic was supposed to be wanting.
Yeah.
Yeah, I mean, we didn't initially have any extender boards, did we? So I had to pull the card out and wire in backplane wiring to bring it to the outside world so we could scope it. So very time-consuming cycle, wasn't it?
Yeah.
And then later on, we did acquire some extension modules.
Yeah. I think that was one of the things, wasn't it, that started pointing towards cables, that you'd put a memory cache board on an extender and it would work, and you put it back in the backplane and it wouldn't, and it was all down to the angle of the memory cables, I believe, was it?
Yeah, exactly, Sean.
Yeah. So yeah, we had a few things to play with there. So so moving on to the RMO and the RO3 side of things. This is probably something for us all to talk about, really, but there are two RMO3s with the system. On looking at them from the outside, they look in great condition. They're not. They were absolutely dreadful inside. And there was also a third RMO3 as well. And what we did is I picked the best looking RMO3 to do the repairs on, which we did, and got that drive working. But as we looked further and further into it, it turned out the drive that we repaired was the spare one that had been bought to try and fix the other two. So the actual RMO3s that came with Scrapbook, they're in the very early stages of refurbishment, but they're in such poor condition. Both of them have got burnt out fans. One of them's got a burnt out start capacitor. We're not sure on the state of bearings, and that's something that we'll come on to as well. But these were the two originals. So this was the internal of the drive. This is after it had had a good clean. There's just a few photographs here. So that was the back of it. So an RMO3 is essentially, the drive itself isn't made by DEC, it's made by CDC, and it's a 9762 CDC drive. And what DEC do is I think there's a couple of modifications possibly to the drive card cage, and then two cables, an SMD-A and a B cable, go into a controller that's in the base of the drive. I'm not sure what that controller is called. Maybe it's what? Sorry,
DCL box.
DCL box, right? And that's it.
Logic.
Okay. And then from that DCL box comes a big, thick, well, we call it like an elephant trunk cable, isn't it? It's got to be 2 inches in diameter. And that's the mass bus cable that interconnects the drive to the actual CPU itself, or to the mass bus controller within the CPU. So this was, again, early stages, bit of dust on there, as you can see, before we give it a very good clean. When these things were live, they were pretty robust. You know, I mean, you wouldn't want to get them dirty, but if there was a little bit of dust kicking around, they were usually okay. I've done lots of head repairs and replacements on these drives, as I guess you other guys have as well. And it wasn't unless it was in a really bad environment where you used to maybe have head crashes. But because we don't have the luxury of spares and new heads and alignment packs and tools, we had to be really meticulous with these drives in terms of cleaning, because we couldn't afford any problems. If you think about it, when the day comes for us to actually spin up the scrapbook discs, we have one chance, and that's it. You know, if there's a problem with the drive, if there's a problem with the heads or anything like that, they could just kill the project there and then. So it's always a bit of a worry, really. Just
had a point there, Sean.
Yeah,
the heads are actually flying over the pack; they're not touching it.
Yeah.
An analogy that I always remember actually is, just imagine a jumbo jet flying an inch above the ground.
Yeah,
that's what I was told.
Yeah, no, that's right. I've heard that as well. It gives you some idea of the context of how these things worked. I mean, okay, by today's standards, it's nothing really, I suppose. But when you look at where this was, 40 years ago, this is pretty cutting edge technology for the day. That's the internal of the drive that we look to refurbish. First of all, I think the date on that filter was 23rd of May, 1990. Was that not the day that we were down there? We were there on the 23rd of May working on this, weren't we?
Yes, we were, because it was my birthday, I remember, on the 25th. So, yeah, exactly.
Yeah.
Into the number of years since the filter was
31 years on to the day, wasn't it? Yep. So So yeah, so the reason then that we identified that this wasn't an original scrapbook disk is because the other two drives had filter dates of 1988, I think it was, or 1989. They were both exactly the same, so they were obviously the matching pair. And you can see there's a fair bit of dust around the intake fan. In general, though, this wasn't in too bad a condition internally.
So, if you go back to that one, Sean, it's probably worth pointing out the ones that we've had to repair. The spindle and the belt, for example.
Yeah. Am I able to do a pointer on this, Jerry? Let's have a look.
Showing on your mouse.
Your pointer's running now, yes.
Yeah. I can see your pointer moving, yeah.
All right, okay. So this basically is the bottom of the spindle where the disc pack sits. You can see and this is the belt coming down here and around the motor. This was the drive motor. This was the brake. That's the start cap. That's when they let go, it smells like a cat's peed inside it. I'll never forget that smell.
Worse, yeah.
And you can see the dust around here. Look, there's lots of dirt and dust, all needed cleaning up.
No, just saying the bits we've had to repair to make it, the spindle bearing that Richard did.
Yeah. So this thing here, which you can, if I draw a line around it, is basically the spindle. It's quite a big piece of kit. That the disc pack sits on top, and Richard will come to that because we replaced the bearings in this. Yeah. Okay.
Well, I can mention that now if you wish.
Yeah. Go for that, mate.
No, very, very briefly. The spindle is a large lump of metal where the disc pack. You had a picture earlier on, Sean. Maybe 3 or 4 pictures earlier where you saw the actual disc area, disc enclosure. Can you?
Yeah, right. So I'll go to that one.
That one there, yeah. Well, what you see in the middle there is the top of the spindle, and right below that, about 6 inches, 7 inches down, is where the belt pulley is attached, which spins the spindle, which spins the disc. The problem we were having was that it would take about half an hour for this specific drive to stop screaming whilst it was spinning. Which is not only is it irritating, it potentially can cause a serious damage to any packs in there or the actual unit itself. So you can't get hold of these items anymore. These drives are so old, the spares aren't available. Certainly bearings for this already fitted to this unit aren't available. So I do spend a lot of time underneath cars, and to me it felt like a bit like an engineering task to remove the bearings from the spindle and refit with new bearings. You can actually get hold of bearings which are similar and will do the job. So really with just some belt spindle pullers and some bearing knockers, was able to replace the bearings from a local supplier, £7 or £8 cost each bearing, and got the thing spinning sweetly. The difficulty, of course, was measuring the height that the pack would then sit when it's all reassembled. That was awkward, but achievable. So now we have a disk drive that spins quietly with fresh bearings, possibly not up to the specification of CDC in terms of the bearings, but certainly functional to allow the units to operate efficiently and for a good 5 to 10 years, I would have thought. It's now a job done. But like I say, the spares are impossible to get hold of. So, needs must, and you have to find ways of making these things work. I think that's an experience that a lot of you will probably already have with the equipment that you guys work on. So yeah, if you want to carry on, Sean, with the rest of the repair.
Okay. Well, there's my mouse. So this was one of the boards out of the drive. Ray, can you remember the story on this one?
Yeah, it was simple blowing one of the 2 amp DC fuses on the, I forget if it was the plus or minus 42 volt rail. The killer was that we borrowed a card, didn't we, from one of the other drives?
Yeah.
And it's exactly the same fault on it. Now, you'd think we caused that, but I assure we didn't. That's a decoupling capacitor. It'd gone dead short. And we had 2 boards with the same shorted cap on it. That was a mystery. That was a mystery, but...
What the other thing that was a mystery there, Ray, was that between the 2 boards, the cap there were different manufacturers, different shapes. They were same value, but the same cap had still gone short on 2 separate boards. So that took a bit of time to chase, didn't it?
Yeah, and on years of working on these things professionally in the 80s, I never ever saw that fault. So that's why it's a mystery.
Yeah.
But anyway, we moved forward after that.
Yeah, absolutely. So that was our drive, all nicely built and ready to spin with a pack loaded. Malcolm, do you remember the problem that we had with this running diagnostics? We ran one of the diagnostics and it failed on, was it track 0 or track 1, head 1?
Yeah, that was a formatter, wasn't it? We were trying to format it.
Trying to format it, yeah, and it would fail, wouldn't it?
And it kept coming up saying, track 0. It was simulating a head fault, but it turned out to be the actual media that was faulty.
Yeah, that's right.
Yeah, we proved that. We proved that, didn't we? By swapping the head cables into the preamp, we swapped 0 and 1, and then the fault moved to the other head, didn't it? Because it was the wrong head on the track. So that's how. So that was just a track 0 of the disc, of that particular disc.
Yeah, and we proved as well that it wasn't the head itself, because it would work on all the other tracks. You could seek it to another track and do the same test and it would work. It was only on track 0. Yeah. So like we were saying, this
spin at 3600 RPM.
Yeah, it's for something that size, it's quite impressive, right? But yeah. So this was the day that we actually managed to get it going, and first of all, spin that pack up, and Malcolm will be able to explain what's going on here, because he was the only one who could remember how to use the test box. So yeah, I'll play this video.
It's going a bit slow, is that, isn't it?
It's a bit jerky and the sound's not there.
Anyway, what it is actually doing, it's doing that is the TB216, it's a CDC test box for SMD type drives and other type drives. It's not a matter of just plugging it in and it works. There's all sorts of keys you've got to add specifically to that particular drive before it'd work. And that's just doing a pure random seek. It's not doing any reading or writing yet, just to get the sort of bearings lubricated.
Yeah, I think the day we went through quite a long process, didn't we? When we arrived to site, we would turn the drive on and just leave the fans running for an hour.
Yeah.
Then we would, I think we loaded the pack, but disconnected the voice coil and left it spinning for another hour.
Yeah.
Before we.
And then manually pushed the heads out.
Oh, we did. That's right. Yeah. Manually pushed them out.
Should I say?
And since then, it's every time we go, we give it quite a hard test and check the heads before we start. And so far, touch wood, next to no head contamination at all. Is there? It's in good shape as the drive now.
It certainly is.
Yeah. So these are some of the things that went wrong with the RMO3. The start capacitor went. That's the smell of cat pee every time. Obviously, if you keep spinning the drive up and down every 10, 15 seconds, it's going to take the capacitor. But I think this went probably on the second time we spun the drive up. It let go with the cloud of smoke that accompanies it. We did the spindles, as Richard's already explained there, and I've got it down as the -12 volt fuse that was going, Ray. That was that capacitor problem.
No, that would be right. I said plus or minus 42. There is a 42-volt supply, but it was on the minus 12. You're right.
Yeah. And yeah, the heads were dirty, but they weren't crashed, which is good. We haven't taken the heads out. The absolute utopia of what we could hope to get hold of in this whole project would be an RMO3 alignment pack. These things are a CE pack. These things were already just so rare that if you think 30, 40 years on, the chances of getting on one is next to nothing. So therefore, we can't afford to remove heads and have them go back in unaligned, especially if we're reading the scrapbook discs, which will have been written with an aligned drive. So we have to live with those heads being in there at the moment and not remove them. But the heads are in good condition, and we clean them with a mixture of lint-free cloth and isopropyl, or Malcolm showed us the way of doing it with a piece of A4 paper and isopropyl alcohol, and wait till it squeaks, and it cleans the heads absolutely perfectly. Lovely way of cleaning them. The carriage rails were in a bit of a mess, weren't they, Malcolm? They were very lumpy, weren't they? But you managed to get in there and clean those.
Ideally, they need to be repaired, but in doing that, you have to take the heads out, which we can't do.
Yeah.
Until we find a CE pack.
Yeah, that would be
if
amazing.
anyone out there knows of one, just let us know.
Yes, please. And then we had a problem, which I briefly mentioned earlier on, that we had a drive that then it was working, then all of a sudden it wouldn't, and there'd be a stuck bit on the Massbus card. So one of the cards within the DCL that I've learned now, that's what it's called, in the base of the drive, failed halfway through us doing our work. And I suppose, you know, these machines have sat there for 30, 35 years, not being used. As soon as you start powering these things up, you're always going to start getting capacitors that fail, or, you know, the thermal shock, thermal stress of things getting warm for the first time. It's obviously going to start introducing faults, and you just have to work around that. And then the final bit with the RMO3s is that there's the two original scrapbook discs, physical drives to repair. Don't know how far we'll get with those. It's just time, really. But if we know that we've got one good drive in the one that we've just been showing there on the video, we can use that to read a scrapbook disc and write it to the Fujitsu drive that you saw earlier on in the video as well. The small in comparison to what's available in those days. It was 134 megabyte formatted Winchester drive that we can make that look like two RMO3s, which gives us a target to restore the scrapbook discs to. That's the hope that we can achieve. So we've talked about RMO3s and PDP 1170s, and I did a little bit of a comparison earlier on about how you could compare a PDP 1170 with a MacBook Pro. Here's another little one. In terms of what storage is on there, they're 67 megabyte formatted. But I did this thing where I compared an RMO3 with my Samsung phone. If I wanted the same storage, I'd need to buy 1,910 RMO3s. They're $63,000 each in today's money. That's $120 million for the same storage as my mobile phone. And, you know, don't even get started on what the electricity would cost you to run it. This is all hypothetical, and we don't really need to do this. So I think probably the last thing I wanted to go through was, how do we get a PDP 1170 running an operating system when you start essentially with nothing, because there's no media or anything like that, no drive media available. And this is what I did. And why is my mouse not working? Okay, can you hear me?
Yeah.
Yep. Okay, I just want to make sure it hadn't hung first of all. I'll try this again. All right, there we go. So how do you build an operating system for a 45-year-old computer? The first line there is, that's the key to everything. There is an application, a simulator called Simh, and Simh allows you to run pretty much any historical CPU. on a Windows, a Linux, a Mac, anything you like. It's a simulator. And SimH is just astounding. I'm guessing quite a lot of you may well have heard of it. If you haven't, you should go and play with it. It's great. And there's a simulator within SimH called the PDP. So what I did, I found a tape dump of the original Rustus installation tapes. It was on a site in Russia. I'm sure it's legitimate. I'm sure it's safe. But anyway, it did the job, so it must have been. So first of all, I downloaded that, and then I attached it within SimH, along with a virtual disk, which I created with an RD54 geometry. We booted from the Rustus installation tape, which took like a second, as opposed to about 10 minutes if it was a real tape drive. And then from that, I could install Rustus onto my RD54 image. The next thing I did, I bought myself a little LSI SCSI controller for my Linux machine, and I attached a physical 1 gigabyte SCSI drive. You would not believe the amount of hassle that's taken in trying to buy a 1 gigabyte drive. It's almost impossible. Anything that small is probably more expensive than some of the biggest drives you can buy now. It's crazy, but yeah, it's where we are. And then what I did, I used the DD command within Linux to take the disk image that I'd created within SimH and put it onto the physical SCSI disk drive. So now I had a disk drive, a SCSI disk drive that I could boot within SimH, but it was a physical drive. The next thing I did is I built a PDP 1193 that I have here with an RQDX3, an RD54, not an RD53. That's my fingers. And we put in there an Emulex, the UC07 disk controller. And you can configure the UC07 to look like pretty much anything you like. I attached my SCSI drive to it, and I could then successfully boot that same Rustus installation that I'd created under a SimH on the Linux machine. So I used that to restore Rustus from the UC07 and put that onto the RQDX3 and the physical RD54. And then we ran the sysgen, which I talked about earlier on, that took 45 or 48 minutes to run. It takes a similar time on the 1193, even though 1193 was the last PDP CPU ever produced. That was opposed to 9 seconds it would take on the Mac. And we added support for RMO3 and for RLO2 drives. The RLO2 drive will become apparent later. Next thing was we took out the UC07 and installed an Emulex SC03. An SC03 is an SMD controller. It's a Qbus quad height card, 2-channel SMD controller. And on that, I attached the drive that we saw in the video earlier on. It's a Fujitsu 2322, which is 134 megabytes. It basically can present itself as two 67 megabyte RMO3 drives. And from that, we could restore the Rustus installation from the RD54 to the Fujitsu drive. I hope you're keeping up with this. You'd think I was nearly finished, wouldn't you? I'm not. Here we go. So the next thing we needed to do, we removed the RH70 controllers because they basically emulate an RM11. I believe it is the disk controller for an RMO3. And we put the SC21 in there. The reason we had to remove the RH70s was because it's the same address rather than changing to alternate addresses. We just took that out and put the Emulex in. We attached the Fujitsu to the SC21, and we installed an RL11 controller and an RLO2 physical disk drive, which I think is 10 megabytes. I think, is it 10 or 5? I think it's 10. I think the RLO1 is 5. And from that, we could boot the Fujitsu 2322. So for the first time, we had a PDP 1170 that we booted an operating system that started its life as a tape in Russia. And from that, we could install Rustus from the RMO3, which is obviously the Fujitsu drive, onto an RLO2 disk pack. So the museum owns quite a lot of RLO2s and hundreds of disk packs. So we didn't have a problem with media. The biggest problem is the media is only 10 megabytes and the installation of Rustus, I think, was about 11. But we managed to maybe just lose a few of the help files and got it to fit. So next stage, we removed the Emulex SC21 and reinstalled the original Scrapbook RH70 controller, the mass bus controller that runs the RMO3. We attached the RMO3, the proper Scrapbook RMO3 drive to the RH70. And we initialized that, installed Rustus from the RLO2. So then we finished with an 1170 with an original RMO3 boot-in and operating system. And that's basically what it was. That's all there was to it. So it's just thought that might have been interesting for people to understand the sort of pain that we needed to go through to do this. So next steps, this is where we are. Every time we go there, we validate how good the RMO3 is in terms of its stability and you know, are the heads clean? Is it still doing the job we want it to do on a longer term? We've got problems with drive belts and things at the moment. So maybe Richard, if you can explain where the drive belt issues have been, and we'll, you know, and see and talk about what it is that you've done so far to find new ones.
Well, put it briefly, when we installed the refurbished Spindle, we took the old belt off the old Spindle, and in doing so, we probably separated and left some of the belt on the old Spindle at the same time. So the belt basically has been there for 35, maybe 40 years, and it's not in its greatest condition. So with a new Spindle and a shinier surface, the belt had a habit of dropping off every time it was spun up. So when the drive spins, the motor applies a lot of torque right to the belt. There should be a tensioning system, which I think is possibly not working either. So it's just a matter of acquiring new belts, and again, these don't come off the shelf. So we've had to find belt suppliers to provide us with the right belts. So on our next visit, we'll take a few samples of belts down, give them a whirl, readjust the drive tension, belt tension, and hopefully that should resolve the problem. I don't really see that as a major issue at all. I think it's just one that we'll just have to find the right belt. Once we've found the right belt, then we'll have a proper source of belts for the future, I guess. Yeah,
of course. So probably other steps we'll probably do is we'll probably maybe re-engineer the RMO3 slightly to bypass the DCL and the mass bus controller. Potentially we'll run that on an SC21, and the reason is that we can attach both the Scrapbook disk and our Fujitsu Winchester disk simultaneously to the same controller, boot an operating system off one side of the off one side of the Fujitsu, and use that as the basis operating system to do a copy of the IAS disk, Scrapbook disk onto a separate media. So the IAS is, like Ray mentioned earlier on, is very similar to RSX11, and the drive pack IDs and the drive formats are all interchangeable. So we may do that just to get a copy of the data off. We've still got to think about that. It's a little bit further down the line. Once we've proven that in essence that works, we've got to test it again. And when we've finished testing it, we'll test it again. And we'll get to a point where we have to take the Scrapbook disks out of their cabinet. So those Scrapbook disks have been, I don't know how long they've been in the cabinet, but we actually have never taken them out. So when they come out, there's always this worry that when we take them out and we mount them on an inspection rig and shine a torch in there, that maybe the surfaces have already corroded and degenerated, and therefore it may even be a lost cause. But we'll wait to that day. We'll find out, and we'll see if they're as clean as the other packs that we have. And if they are, then so long as we're very confident in the state of the packs and the state of the drive, then we should be able to run them up quite confidently, I think. And when we've done that, when we managed to get a copy of those disk images, they can be handed to the museum and they can be run on a simulator. And therefore, maybe restoration of the original operating system and applications can be done in a safe environment once we've got a copy. But ultimately, where we've got to is that we have the hardware running as it was, a full system that we could run original or copies of the original scrapbook discs to demonstrate to people visiting the museum. It's all about space, though. Probably most of you are aware, space is always at a premium, especially in our museum. So, does this go on display at the expense of other systems? Who knows? But our job isn't really that part. Our job is to reconstruct this system, get it where it's working, and we're confident in its ability. And that's where we are. Malcolm, Ray, Richard, you got anything else to add?
How much time have we got, Sean?
We've got about we've got half an hour altogether if we want to do some questions and so on, and see what people have got, or if I haven't gone through the chat yet. So what do you want to, have you got anything else to mention, Ray?
No, I've just got my spreadsheets, which, just to maybe just go through and show how we tackled some of the faults and things. So basically, the way we fix these things, it's different to what the process we used to use when we worked on them professionally. You get a field call to a dead machine or a malfunctioning machine. You'd go out there, and if you hadn't got it fixed within, say, half an hour, 11:70 or an hour, a try reseat, etc., it was almost taken out of your hands. Tech support would come in with a full set of replacement modules, and hopefully it get fixed like that. We don't have the benefit of unlimited modules on this project. So in some cases we've had cards in both machines which are faulty. So we've had to repair down to component level based on the results of the diagnostics. So if I can just, hope this won't take too long. I've been keeping track of things we've done on a spreadsheet. It's not always been updated at every visit. I apologise for that. But anyway, this memory management problem 2, here we are. So the analysis, this was all homework which was done off-site, away from the museum. Basically mapping out all the expected actual values and identifying bits that were stuck. And all the ones in red here were the ones that the diagnostic was basically telling us we're stuck at 1, and there should have been 0. And by going in on the front console panel and operating the 1170 switches without running the diags, we could actually see this easier without running diags. You just deposited a value into the memory management register 2, and the bits there, for instance, which were zeros, you read them back as 1. So we could then see the problem. So the next thing was to trace these bits through. Just a minute, let me shut them. Right, so these bits, they appear on the column 0 again here. And so I went through the 1170 engineering drawings, which we acquired courtesy of BitSavers on the internet, and traced every one of them through from when they started off from the bus address multiplexer all the way through to when they became actual MMR2 bits, if you like. So on the next visit, we went down and we actually scoped some of these signals through this progression of through this path. At the top, you'll see which module was involved. So they started off on the data paths module in slot 6, and through the backplane, went through the not item address paths, system address paths, and then onto the SSR module, which was in slot 16 there. And we found on the SSR module through scoping that, yes, some of the bits were actually missing. Changed the boards. All 3 boards got replaced with no difference. So we then came to the conclusion that it could be a faulty backplane, and reluctantly we took the backplane out of the spares machine to prepare to change it into the other machine, into the scrapbook machine. But then we found that it wouldn't fit because it was a different revision, mechanically would not fit. So we resigned ourselves to having to do continuity checks on the backplane, i.e. for bit 6, for instance, from this black backplane pin on the DAP module, CL1, to find out whether it went to FR2 on the SSR module. And lo and behold, we found an open circuit. And so we thought, well, we've got the right pins, are we doing something wrong? So we compared with the backplane that wouldn't fit, and we found we did have continuity. Anyway, to cut a long story short, got a strong, very, very strong light out, shone it into the slots, and we found a piece of deck tape lodged into the slot on these backplane pins here on the SSR. Sorry, on the SSR module. Remove that tape, continuity is good, and the diagnostic passed. So this is the bit of the logic diagram where we found these signals. Bit 6 here is the example one I'm using, and you'll see on the output of that chip E77 it becomes an MMR2 bit. So this is actually part of that register. EKB failing there. Yeah. So that was the diagnostic failure we were getting. So that was the failure we were getting. You'll recognise those errors there that I tracked on the homework session, basically. And then we were able to see the diagnostic passing after we did the repair. And so for every fault, every hard-on fault, we had to do some little homework exercises like this in between visits to decide what to scope next. And well, it was very fruitful actually. And the only thing I think back to is, how do we manage when we work professionally on these machines? I suppose the answer was that the modules got taken out. They went to a specialist workshop that were working on these things day in, day out.
Me mainly.
But as I say, this turned out to be a piece of tape stuck in the backplane. Yeah. Really old, brittle tape, which with my 65-year-old eyes, no chance of seeing that without a strong light. Mm-hmm. So loads of other examples of faults that we had, but this is the method we used to fix the worst ones.
Yeah, I'd just like to add there where you've got the how you followed the track through. To get to that point, you had to use the diagnostic listings to find out, which again was loaded from BitSavers.
Oh yeah, well that's on this tab there, Malcolm. You provided us, you provided us the knowledge with when we got a diagnostic failure. I don't have that knowledge. You had the knowledge to go in there and from the PC of the diagnostic explain what the diagnostic was attempting to do at that point.
Then we had to relate that to the engineering drawings.
Yeah. So we made good use of the diagnostic listings as well.
Normal problem.
Sorry, Mark. No, I'm just saying we've got loads of documentation we've gathered throughout this project.
And what I was going to say, the main problem we did come against, if we found a faulty chip, it's a case of whether you find a new one or a replacement chip, because half the chips are obsolete now. And that's where donor modules came in.
That's right. There's a lot of 7.4S, generic 7.4S chips, which we can still obtain. But is it the DEC Unibus drivers and receivers, Mal, the 86 series?
8641s and that sort of bus drivers.
Yeah, just not made anymore.
Yeah, so it's a case of finding a board where you can desolder it from, which in itself is quite hard because the solder's old and won't melt. Finding the board is difficult enough.
Yeah.
But we get there in the end.
do. So good stuff. Actually, Ray, I've got to say, I didn't realise I was probably down the other end of the workshop in Bilton Road doing other stuff, because I didn't know you went through on that level. That's
well, I enjoyed it. I mean, this is the joy of this project. Really, I really enjoyed doing this type of stuff. There's another page where we analysed what our machine looks like. So this column here is our actual machine, the address mapping, etc. That's the physical memory. We've got 512k words, etc. But yeah, I spent hours doing it, but it's labour of love, really.
It's so much fun, isn't it?
Yeah.
That's going to be an age thing. I find it fun as well. So, yeah. Anything else do you want to add, or Richard? Do you want to add anything else?
No, I think Ray's covered the process involved in the fault finding technique with the 1170s. I think all I can add is the 1170 was built by an organisation that really had design in its heart, and the 1170 is just a solid machine composed of a whole bunch of integrated circuits which are connected by wires, and it's the joy of tracking a fault from one board to another, ending up at a 74 series chip and then be able to swap it out is just really exciting. So yeah, it's a great bit of kit. Sadly, it's old kit. It's that sort of technology doesn't exist anymore. And the new computers, it's just all plug and play and throw away. That's what makes this so enjoyable. So that's all I have to add, really.
I think from my side as well, that just even now trying to, and I think I sort of know how computers work, and I've been in cybersecurity for many years now and so on, but even thinking back to what these guys were doing in the late 60s and early 70s, it's just incredible what was achieved from, like you say, a bunch of integrated circuits and some wire. It's absolutely amazing. And that sort of, I mean, all right, the skills that exist today are on a completely different level, but the ability to do what we're doing, I suspect those skills are dying, and because there's no need for them anymore. So it is quite satisfying to be able to bring these things back to life.
Yeah, and of course the last question I've got to ask is who have we got that still knows about the actual scrapbook application? Because we don't know a thing, do we? So we've got to find somebody somewhere that either knows how it ran, or we have to reverse engineer it somehow.
Yeah, I suppose in one way, hopefully we've got skills who can do that. I know it's not my skills. And
Len, who we've got on the meeting at the moment, knows about Scrapbook.
Brilliant.
Yes, I can talk a bit about that if you want.
Oh, yes, please.
I was at NPL using Scrapbook and knew David Yates and others involved with the project.
Yeah, please.
That'd be great to hear, yeah.
Right. Okay, I've got as much time as it takes, basically. I was the previous owner of this machine and donated it back in 94. So the last date it actually ran was 94. The dates on the filters were when it was with Shell and professionally maintained. We ran it until it came to the museum in 1994. So that would be the last date it ran. I had bits of it on briefly at the Computer Museum, but it was in storage. Unfortunately, yes, it had been stored in less than ideal condition in derelict buildings at Bletchley for many years. So that possibly accounts. It was a working machine in 1994. But I have got the startup procedures for it. You should have the IAS disk is Scrapbook. It should also have on it commented source code. The Shrivenham BCPL compiler, Scrapbook is written in BCPL, and other utilities. Also with it was an XXDP disk in the collection. They were in a big sort of grey cabinet. I think some of the disks may have got separated, but there are a number of data disks. But essentially, the original RMO3s were the blue-fronted panels. The brown-fronted panel RMO3 came from a maintenance company called Team that we were involved with way back at the time.
Team.
Yeah, we worked for them, didn't we?
You worked for Team,
oh, no, they joined us.
Yeah.
Okay, right. So that's another story completely, but they were doing another job for us and they gave us one of these as a spare. As it shipped to Bletchley, one of the blue ones had already, the blower motor had already burned out on one of the blue panelled ones, and we were using the brown panel and a blue panel pair to run Scrapbook. On drive 0, I think it's drive 0 and drive 1. On drive 0, you have IASys, which is Scrapbook program and software, and the day's journal. On disk 1, you'd have the database disk. And then they would be backed up sequentially, separately, overnight.
So both RM disks need to be running?
Yes, Scrapbook won't run on one disk. You need 2 disk drives. Scrapbook won't run. It is looking for drive 1, which also must have a seed disk known to Scrapbook on it. So there are a number of the disks which have this on it, but I think the problem, when we got it from Shell, they very carefully obviously wiped all their database disks and gave them to us. So when we tried running Scrapbook, it didn't work and we had to reconstruct this disk on drive 1. With that disk, you can then build a database, but that's essential. I have got all the buzzwords needed to start the whole thing up somewhere. I think they may still be with me. You may have copies. At the museum, in the archive, there should be two archive file boxes with the complete printed source code on it of NPL Scrapbook. That I think that came from, was it Mike Stevens at NPL when they were clearing out. He knew I was interested in the project and they were just throwing stuff out at NPL at that time, and that was due to be thrown away. So he said if we just come in, he'll give it to us. So that would be a printed copy of a version of Scrapbook at NPL. The NPL versions had a lot more facilities on than the version you have. You have the commercial version from either Triad or BT Milepost, who Triad were the first people who marketed it commercially. Milepost in Leeds at BT took the contract as suppliers under the brand name Milepost Business Systems. So we do have a BT Milepost system on the 1170. The 70 itself would have had 3 racks. The third rack is still in D block under asbestos restrictions, unfortunately. But it does have the Scrapbook provenance on it. It's got a nameplate that says Scrapbook and the various bits and pieces. But we rebuilt it as a two rack system partly because it takes up less space and partly it just looks nicer. And of course, as these DEC systems were made, the first rack on the left-hand side had the processor and 1 or 2 other modules. The second rack will be memory, but there's only 1 memory crate, so you could fill the second rack with more memory, up to, I think, 4 megabytes. The third rack would be for comms. In this case, it was online. It had modems and barriers to connect up to the telephone network. And there should be a crate. We put that crate in the second rack. So the second rack should have both a memory and a comms crate. I don't know whether you have the comms crate for it with various multiplexers and serial interfaces and possibly modems.
Ray, was there not a DH11 backplane in the BA11 box that's in the second side, on the right-hand side of that rack?
No, we thought it might be a DH11. When I looked at the module numbers, there were various different random modules. I've got it written down somewhere what they were. But so no, there was no DH11. But I'm just thinking,
there'd be serial ports for comms. I mean, DH and DZs come to mind, but
DZ11 makes sense, Len, because we've got some distribution panels which I showed you was on the slide earlier, which are actually DZ11 distribution panels. So that makes sense. Yeah.
Okay, so it would have run local terminals at Shell, but also modem, dial-in modem. So there'd be both local serial ports and modem ports And this would be in the third rack in a comms crate to control it of some sort. I just don't remember exactly what, but that was the system as we inherited it.
Yeah, the modems probably did also run on the DZs because they've got partial modem control on there. So on the scrapbook application, how many users did that support? Concurrent users typically were on there then?
It was a small system compared with, I mean, you're talking about 20, perhaps 20 users. I'm trying to think the NPL scrapbooks. Well, I think that will all be in David Yates's book, Turing's Legacy, which is in the TNMOC library. But I'm thinking about, 30 simultaneous users, something like that.
Yeah.
It was the NPL one was on a modular one, a CTL modular one machine. Then, of course, it went on to DEC because DEC were popular machines. So in the real world with Triad and Milepost, they wanted it on DEC machines. CTL also migrated it to the ITL, the bigger ITL machines, which BT used internally for internal scrapbooks. It was also put on, I believe, a Siemens IBM clone for the European communities. So many of these were sold across Europe and the UK. There's a spin-off of a lookalike by Xionics, which was sold through the old GLC. Ministry of Defence had some. So they spread around quite widely, but not at the consumer level, other than Prestel. Now, Sam Fadida saw a scrapbook at NPL on one of the open days, and now we don't have the direct details. I've spoken to David Yates about this, but neither David nor Sam are with us anymore. So this is perhaps my memory, and I'm now 81 years old, so it's all disappearing into the past. But Prestel looks like, from what I've discovered talking to people, was not a clone of Scrapbook, but it used the ideas of Scrapbook, basically the page system, rather than scrolling system. Back in the day, of course, dumb terminal VDUs scrolled because teletypes had rolls of paper in them. And Scrapbook came as a page system. Prestel was much the same, but Prestel had a different remit. It had to have a large number of users at the expense of security, whereas Scrapbook was security at the expense of a large number of users. That seemed to be a main design feature. Prestel, as I say, was also the other remit for Prestel was to use the then post office telephone network in the evenings. It was to get people using it. But Prestel has direct connections with Scrapbook. And of course, Prestel was what became level 1 view data. Then we had level 2 view data in France called Teletel. And I think level 3 view data in Germany called Bildschirmtext. And beyond that, I think Japan had a system and the Americans had view data systems. Now, Tim Berners-Lee, we have asked him this, he never knew about Scrapbook at all, but he would have been aware of view data systems across the whole of Europe. He could hardly have been unaware of those. So a lot of the things that were in both the early Berners-Lee implementation at CERN, and of course, the web we know today is nothing like that. I mean, that is more some of the Americans who developed this multimedia and other aspects. But even things like Twitter had been implemented in Prestel. A lot of what is on the web now, and we had something very similar to Twitter running on Prestel. But for whatever reason, BT closed Prestel at the point where on the research machines, they'd something called Picture Prestel, which did give picture, reasonable quality picture resolution, similar to today's JPEGs. But at that time, Prestel and all the research was closed down and abandoned, and it was another, 10 years before the web got going. But of course, to be fair, back in the Prestel days, for a consumer to have a terminal like that would be very expensive, and most had adapters that plugged into a television, which gave you the standard sort of fuzzy Prestel picture of the day, which was why it was 40 column by 24 lines. There were 80 column view data systems used by the financial services and travel agents. In fact, I think I have a couple of MicroVitek 80 column view data monitors from the financial industries because they have a buy and a sell key on them. And of course, Scrapbook comes after Ted Nelson's Xanadu. Ted Nelson defined the word hypertext. And of course, before hypertext on computers, you had hypertext in paper form for hundreds of years. So the concept of hypertext is not new. Anyway, I've probably spoken enough about the bits and pieces I've had. So are there any other questions relating to Scrapbook, NPL or its successors or predecessors that people might be interested now, or maybe at some future meeting?
I had one question there then, which was, you mentioned that the Scrapbook system was originally 3 racks.
Yes.
Would there by any chance be a tape drive in the third rack?
There was a tape drive when we got it from Shell, and I don't think there had been a tape drive. I'm quite surprised that there was a mass bus. We only had the mass bus to connect to 2 RMO3s.
Okay. It looks like it was supplied with a mass bus tape controller, but never used.
No, there's no mention. None of the documentation I've got from Shell, none of them mentioned tape. I just always assumed they'd done backup onto disk backs, and there would have been utilities for backing up the disks, which is why, as I say, the disk 0 will have the day's journal on it of the day's transactions, and that is written both to drive 0 and drive 1, so it's written twice over. And when you do the backups, it means if it goes down at any time, you've only lost sort of 1 line of text, basically. You can restore everything. Or should you?
Yes.
Fascinating.
Indeed.
Anybody else?
If anybody's interested, actually in Bilton Road, there's, I think it's an 1184 that came from Dungeness. And I think it's got a tape drive, deck tape drive on it. And there are some tapes that came with it that have got BCPL on them.
Right. Is that the tape drive? Is that a Cipher, the black one, the F880 front loading drive? I think that's there.
It's a front loading drive, but I don't know which model it is.
Yeah, I think it's a Cipher with the PerTech interface. Malcolm, you had a look at it, didn't you? I think
TSV05.
It's a what? Sorry,
TSV05.
Right.
It is a Cipher F80 copy, I believe. Is that true, Rich?
We had kind of got to the end of our slot.
Oh, yes.
And I don't see any other questions or comments in the chat. There was one comment from Ellie Connolly at NPL who says they had 220 users in the heyday of the system back in '77.
That wouldn't be simultaneous users. Yes, it'd be a bit. I've got a list of all the Scrapbook. There were 3 Scrapbook machines at NPL, and as I say, it was the first practical machine to work across interconnected networks. And I say that carefully because the internet hadn't been invented properly then. And ARPANET existed as a separate network to which we were connected. But we did have Scrapbook working across the NPL network and the European Informatics Network. So we were the first to demonstrate a hypertext system across interconnected networks.
Thank you.
Right.
Was that DECnet networks?
No,
or X25 or?
No. The NPL was a prototype packet switch network from Donald Davis, and the European Informatics Network was something else. I don't know.
Okay, yeah.
But all these were connected together, along with Janet, the Joint Academic Network. I think Kirstein at UCL was responsible for a lot of this. So, but we did run a demonstration across Europe from the NPL network across to the European Informatics Network. So that was a first. And that is in David Yates' book, the Turing Legacy. So that is mentioned more fully in that book, which I suggest
to read, I think,
for a lot of the factual information. as I say, some of it is like the Samford-Eder connection and Prestel connection is not documented fact, and unfortunately, it's too late to unless someone finds this in an NPL report somewhere. But the connection is sort of circumstantial and rather than proven.
Great.
Good.
Well, I think that's it from me, certainly. So I'm going to hand back to Jerry. And,
okay.
Great, good stuff.
This is the lecture you've just been watching, everybody. If you're interested in becoming a volunteer, if there's anybody here who isn't already a volunteer, then we are holding a recruitment open day on Saturday, July 24th. Details on our website. The next lecture is actually tomorrow afternoon or tomorrow evening when Dr. Mark Baldwin, also known as Dr. Enigma, will be giving a talk about the ultra secret, how Frederick Winterbottom spilt the beans, which is basically about how Enigma was broken during the war by the British and also by the Americans and by the Poles. And we have other meetings, other lectures coming up in the following 2 weeks. So that's all I'm going to say. I'd like to thank Sean and colleagues for their very interesting talk. And
no problem.
I will now close the call. Thank you very much.